All right, so today in Algebra 2, we're going to look at 2.4 complex numbers and operations. We're going to do 2 days on this, so today will be day number 1. Our essential question for this section: how can you represent and operate on numbers that are not on the real number line? After today, you will be able to solve problems with complex numbers. So first we need to talk about what is a complex number. So the complex number system includes numbers that are not real. The imaginary unit I is the principal square root of -1. Therefore, I squared is equal to -1. Complex numbers are written in the form a plus bi, where a and b are real numbers and I is the square root of -1. Complex numbers include all real and all imaginary numbers, as well as the sum of real and imaginary numbers. So we're going to start out nice and easy. Just identify the real and the imaginary part of each complex number. So the first one we're going to look at, -6 plus 4i. The real part, -6. The imaginary part, 4i. The next one, 7 minus I times the square root of 2. The real part is 7. The imaginary part, -I square root of 2. The last one, 1/2 I. The real part, there's not one. So I'm just going to put a 0 with a line through it to show it does not exist. Imaginary, 1/2 I. So now we're going to talk about adding and subtracting complex numbers. So to add or subtract complex numbers, you simply add or subtract the real parts, then you add or subtract the imaginary parts. So the real part, 4 and -11, are going to get combined. So I'm going to have 4 plus -11 plus, then I take the imaginary parts, -7i plus 9i. So 4 plus -11 gives me -7. -7i plus 9i gives me plus 2i. That is my answer, -7 plus 2i. We want to make sure that we put it in standard form, a plus bi. The real part always comes first, then the imaginary part. So number 2, notice now I'm subtracting, okay? So basically it's going to distribute a negative to all of those. So I would have 6 minus 2, and then I'm just going to put a plus here, okay? And then combine my negatives, or sorry, my imaginaries, 8i minus -5i, which turns that to plus. So 6 minus 2 gets me 4. 8i plus 5i gets me plus 13i. There's my answer. Number 3, again, I'm going to have 3 minus -4 plus -2i minus i. That subtraction is what I put in my parentheses. 3 minus -4 turns to 3 plus 4, which is 7. -2i minus I turns to minus 3i, so 7 minus 3i is our answer. And then finally, we've got -4 plus -2, and then plus 6i plus -9i. -4 plus -2 leaves us with -6. 6i plus -9i turns to -3i. So -6 minus 3i. Okay. All right, next we're going to look at solving quadratic equations using square roots. Remember that I is equal to the square root of -1, so you always pull the negative out of the square root as an I. Recall that you will always have 2 answers when you take the square root. So when you put the square root into the problem, you have 2 answers, both your positive and negative. So number 1, x squared equals -9. X squared is already by itself, so take the square root of both sides. So I get x equals positive and negative. The square root of 9 is 3. Then the square root of -1 comes out as I, so positive and -3i. Those are my 2 answers. Number 2, x squared equals 16, square root of both sides, so I get x equals, again, positive or negative. Okay. The square root of 16 is just 4. I did not have a negative underneath my radical, so no i's. X squared equals -5, take the square root of both sides, so I get x equals positive or negative. Okay. The square root of 5, I cannot break that down anymore, so that's going to stay the square root of 5, but the negative comes out as an I, so x equals positive -I times the square root of 5. And the last one, x squared equals -72, take the square root of both sides. Right? So x equals positive -72, I can do factor tree on that. So that's 9 times 8. 9 breaks down to 3 and 3. 8 breaks down to 2 and 4. 4 breaks down to 2 and 2. A pair of 2s, a pair of 3s, a 2 that got left behind. Let's see. So here I have x equals positive or negative. 3 times 2 comes out as 6. That negative came out as an I. What got left behind was the 2. So x equals positive or negative 6i squared root of 2. All right, let's go back. Factoring a sum of squares. We already have looked at factoring a sum of differences. Remember, sum of differences is where the first term and the last term are both perfect squares, and it's a subtraction sign in between. They're binomials. Remember that factor two, you take the square root of both the first one and the last one, 1 plus, 1 minus. So now we're going to do factor sum of squares. It's the same thing, only this time, first one and last one are perfect squares, and there's a addition sign, hence sum of squares. Okay. It's still, I take the square root of the first and the last, so that's my x to my y, x and my y, 1 plus, 1 minus. But since I'll be taking the square root of a negative, that's going to be a yi and negative yi. Okay. So number one, factor 12x squared plus 3. Well, right now, all that I can do is GCF, right? Because that's not a sum of squares. So 12x squared and 3, they have a 3 in common. So if I pull a 3 out, I get 4x squared plus 1. I just created a sum of squares. Okay. So we created a sum of squares here. So now I need to factor this down. So it's 3. I know it's going to be 2 sets of parentheses. Square root of 4x squared is 2x. So 2x plus 2x minus. Now it's this number with an I. So the square root of 1 is 1. With an I is just I. So 2x plus I, 2x minus I. I cannot forget about the 3 that I factored out at the beginning. So 3 times 2x plus I, 2x minus I. 4x squared plus 25. They're both perfect squares. It's an addition sign. So I'm going to have a 2x plus 5i and a 2x minus 5i. That's my answer. Number 3, 8y squared plus 18. They're not perfect squares, so I look GCF. What do they both have in common? They both have in common a 2. It's the biggest number we can take out. So we've got 2 parentheses, 4y squared plus 9. Again, look at what I've just created. I just created a sum of squares. So now I can factor that. So it's 2. The square root of 4y squared is 2y plus the square root of 9, 3. But since it's sum of squares, 3i. And then 2y minus 3i. So that whole thing is my answer. Now we're going to look at solving a quadratic equation with complex solutions. Okay. So remember that when we were solving quadratic equations, we're just finding the zeros or the x-intercepts. And again, we're factoring it, right? And then setting our factors equal to 0. So number 1, x squared plus 4 equals 0. Okay, it's a sum of squares, so I can factor that. I know that's going to be x plus 2i and x minus 2i. Set both of those equal to 0. So here I get x equals negative 2i. X equals positive 2i. So my two answers, I can write it, leave it like that, or write it as plus or minus 2i. Okay. X squared plus 49. Again, they're a sum of squares. So I know it's going to factor. Okay. So x plus 7i and x minus 7i. So again, I get x equals negative 7i, x equals positive 7i. So my two answers, positive and negative 7i. And finally, 9x squared plus 25 equals 0. Again, it's a sum of squares. So this is 3x plus 5i, 3x minus 5i equals 0. So these both equal to 0. So here, I would get 3x equals negative 5i, divided by 3, x equals negative 5i over 3, which is the same thing as negative 5/3 I. I'll get the same thing over here on the positive. So my answer, x equals positive or negative 5/3 I. Okay. All right, that's where we're going to stop for day 1 of our complex numbers. Tomorrow we will pick up with multiplying and dividing complex numbers.